In this example, a construction worker is pushing a rock whose mass is 300 kilograms. We know that the worker is exerting a force of 400 newtons. It's directed to the north because he wants the rock to accelerate to the north. We also know there's a frictional force. That frictional force opposes motion, so even though we don't know the size of the frictional force, we know it's oriented to the south. There's one more thing we know. We know that the rock is accelerating with an acceleration of 0.12 meters per second squared north. Okay, those are all the things we know. What we need to do is try and figure out what's the value of that frictional force. Well, first we have to think about what we've just learned. Forces add and subtract. So I've got two forces working on this rock, the worker's force and the frictional force. They're opposing one another. So the total force that's acting on this rock is the worker's force minus the frictional force. Now we know the value of the worker's force. That's 400 newtons. So we could stick that into this equation and get that the total force is 400 newtons minus the frictional force. Now remember, we want to figure out what the frictional force is. So we've got to figure out some way to get a value for the total force. Well, it turns out I can get that from Newton's second law. Remember, Newton's second law always deals with the total force exerted on an object. The total force is equal to mass times acceleration. That's Newton's second law. Well, it turns out we know everything we need to calculate the total force this way. After all, we know the mass, that's 300 kilograms. We also know the acceleration, 0.12 meters per second squared north. So in the end, we can evaluate the total force as 300 times 0.12, that's 36, and then the unit is kilogram meter over second squared, which of course is a newton. So we know that the total force is 36 newtons. Well, think about what we have here. We know the total force is 36 newtons, but up above, we have an equation that says total force equals 400 newtons minus the frictional force. So if we take this 36 newtons, we know that's the total force, and we put it into that equation, we find out that 36 newtons is 400 newtons minus the frictional force. So in the end, what does the frictional force have to be to make this equation work? Well, if the frictional force was 364 newtons, then 400 minus 364 would be 36. So that tells us that the frictional force is 364 newtons. What's the direction of the frictional force? Well, it opposes the motion, right? The motion is towards the north. Friction opposes the motion. So the frictional force is 364 newtons to the south. It's important to understand what we did here. We have this equation, Newton's second law, which deals with the total force exerted on an object. Now, when there's only one force exerted on the object, the total force is equal to that force, no problem. However, in this example, there are two forces exerted on the object, the worker's force and the frictional force. Newton's second law only tells us about the total force. Well, the total force is the worker's force minus the frictional force. So when we use mass times acceleration, that's only giving us the total, which is the worker's force minus the frictional force. Since we can figure out the total force, and since we were given the worker's force, then we can figure out the frictional force, but we have to think about it. That's what makes these problems difficult.